Hey guys, how's it going? And welcome to Ridgid multi-tool repair. So this is my Ridgid multi-tool, or oscillating tool as they're known. Now, one of the things you're going to want to do is get the model number off of your tool and download the appropriate diagram. Okay, they do have an older version of this tool, which is kind of looks exactly the same, but it kind of probably isn't 100% the same. They have changed some things like switches, for example. Anyways, so I've had this thing for, well over a year anyways, and it finally bit the bullet. And I thought, well, I didn't get the extended warranty on this one, and even if I did, I'm still not willing to deal with the company in North Bay that deals with these, because, well, I've had some bad experiences with the guy. So yeah, to heck with warranties. And now Ridgid has discontinued this tool. They've replaced it with an 18 volt with a slant style battery hookup, which I may eventually have to buy one. I do have a larger version of this tool, an 18 volt, but it's too big for working on RV trailers with, which is one of the things that I do. And anyways, this is the perfect size. So I'm not too sure about the other one yet. I'm still kind of thinking, well, I don't know. Let's see if we can fix this one first. So there's two common problems that are going to happen with any cordless tool. But specifically with this one of two things as well, is either the switch is going to puke on you, okay? Because you're not supposed to run these things till the battery dies kind of thing. But when you got to get through something, you got to get through something, okay? I mean, you know, but they also have their limits as things you're not supposed to be cutting through with, which I've done a few times and still successful, but not supposed to cut through really super thick wood. And I wasn't at the time. I was cutting through some thin paneling, which this thing should just eat for breakfast with a good sharp blade. But, yeah, it just kept dying. I thought, well, maybe it's my battery, because, you know, we figure, you know, batteries are usually an issue, right? Lithium batteries. They get used a lot, and eventually they just puke. It's 12 volts, come on, you know, but not in this case. In this case, two things can happen. One is the switch. There's a little board on there that also controls the LED panel for your battery level, and, you know, probably part of the cutoff circuit is in here somewhere to say, hey, not enough juice, so you don't completely destroy your battery, right? Well, the other problem is vibration. Vibration is a huge thing with these tools, no matter who makes them. And one of the common things we find is one of the wires will break because of all that vibration in the tool. In this case, that's exactly what has happened. Because when you pull the trigger, you still get power going to the circuit, so you're good, because the light bulb still lights up, right? Now the light bulbs, by the way, also can die on these tools, whether it's a drill or a multi-tool, doesn't matter. And that's fine. You can buy a replacement bulb if you want to. So you get the specific one. It's just a plug-in kind of deal. Way you go. But it also means ripping the tool apart in little tiny bits and pieces just to change the bulb. So how bad do you want your little light? Okay. So in this case, we have a broken negative wire that we need to replace. Now I saved a few steps to save some time on the video. So I've already taken this thing apart. And there's not a lot inside. This is your little plunger, so when your head goes on, it unlocks the power switch. Okay? You got your rubber grommet protector for the gears. That has to be on there. They do give you a spare with the tool. This one is actually fried now, so I got to grab my spare one. You've got your locks. Okay? This little metal tab. You've got 6 screws, and then this little metal tab. Make sure you pull the metal tab out. And you can do that with just a little jeweler's screwdriver, a little pick, and just pop it, and it'll come out, and then your tool comes apart. And of course, you got your left and right and trigger lock when your head piece is on there. So we need to replace the wire. It's not just a matter of reattaching, because now that it's broke, it's a little shorter. We actually have to replace it. So you need to get the same or slightly thicker gauged wire. Slightly thicker may actually work better, a little bit more longevity. So we're going to check the wire gauge here in a minute. So anyways, to also save on time, I'm going to go ahead, remove this stuff, strip the wires, check them, and then we'll come back. Alright guys, I've checked out the wire gauges that I picked out, and these ones are a little thin, so we're not going to use those. And I had this red wire that's got kind of like a flexy silicone coating on it, which is good. Takes up a lot of heat. Anyway, so our little black one, pulled it out, and of course it's a little shorter now just because it broke. So I made these ones just a little bit longer because I wanted a little bit extra length here. So next thing we got to do is we got to tin these ends, and for that we do need soldering paste, which is a must. If you're going to do soldering and you're going to be serious about it, you need soldering paste. So otherwise you can get very bad, poor connections. So we will get these ends tinned. Now of course we have positive and negative to worry about, and I'll show you a little trick there in a minute as soon as we get these tinned up. Now I'm going to go ahead and I'm going to replace both ends, both sides, because you know the way I look at it, if one side's going to go, the other side will probably be the next victim, so might as well replace them both at once and save yourself ripping it apart again for a couple more years. Hopefully this is permanent, because this wire is just a little bit thicker, not by much. Okay, so now we've got them tinned up. You want to have basically a little shorter end and a little bit longer end. The longer end is going to go to the motor side. And then of course our shorter end is going to go to the switch. So we want to make sure the hole on the switch is cleared out as best as we can, so we can hopefully shove that in there. And it doesn't always work out perfect that way. So when we do get into a situation like this, we need to drill that hole out. This can be a little delicate to do, but sometimes you just got to do it because it has to be a good solid connection in there. That should do the trick. I'm a real big fan of Ridgid tools. I really love their stuff. And the only tool I've ever had any real issue with has been their oscillating tool. There we go. Out of the way. Thought I had a little cleaning brush in here. No, apparently not. Okay. Perfect. So that's what I want for this side. So we're going to dip it in the flux again, even though it's already tinned. And we're just going to shove that right in the hole just like that. Okay, so let that sit for a second. And then we'll just go ahead and get this prepped. Now, this doesn't have to go through the hole, but you can if you want to. So you can clear out the hole. For that, we're going to need a solder sucker. Okay. Okay, so let's see if we can. Now, using the holes over again will make a good strong connection. There we go. So we want that about halfway down and a slight little bend to it. It's going to bend a lot easier in a second when we heat it up. I have to block your view a little bit for a second. There we go. Voila. Now that's repaired. You're going to do the exact same thing on the other side. So that's why I'm only showing you one side in this video. Now, we did use a red wire, and we were using red on both sides. We got to know which one's negative. So get a Sharpie marker and just color this. You don't have to do all of it, but enough that you know it's actually black. You can also do this, and that's put a negative sign on the motor. And voila. And these motors usually are marked, but I'm just doing an extra little bit of precaution so that if I have to take this apart again and get the exact same problem, then I'll know which side is negative, which side is positive. So I've never seen a switch fail on an oscillating tool yet, but we have seen the wires fail, okay? There's a little board in here that can fail as well. From what we found inside, it's kind of a you know, but generally very rare. And it's more the speed control is what it is that can go down on you. But I mean, we run these tools full bore. We're not wussies with our tools. You know, we treat them the way they're supposed to be. Tools to work. So this is the left-hand side here. This is where the screws actually go into. And this is where we're going to reassemble after. Get all that done. But I'm going to go off camera, and I'm going to go ahead and I'm going to fix this side up. And make sure that that's all done. Because even though it's good, and it's an area that doesn't usually get affected, I want to go ahead and just do it anyways and get it over with. So I've got lots of length there. I'm good. So that's all fine. By the way, don't lose the spring on the front here. It doesn't come off too easily, so you shouldn't lose it. But if it does come off, make sure that you find it again. Now, these connection points, always check your connection points too for heat fractures. This is something that I'm going to go over top of all these connections off camera. I'm going to reinforce those connections because that's for the battery power. And I want to make sure that they're also good, you know. So, anyways. Instant for you, but I will be back once I have got this fixed, and then we will reassemble the tool. Alright guys, well we're a little early, but that's okay. So I'm opting out to replace this wire. It is in great condition. It's not loose anywhere. It's not flexing, so we're going to leave it. However, I did find this red wire for the battery has a bit of casing that's stripped on it, and from vibration. It's like, oh man, we got to fix that. So there's a couple things you can do. Hot glue is not one of them. Don't do it. Okay, these things are very tightly put together. Now you could use a little bit of 5-minute epoxy, or if you have a wife, grab her red nail polish if she has any, or any nail polish. I actually get my own nail polish, not for my fingers, but I use them for marking wires. And it's also a good repair to repair wire with, because this is not a wire that you can easily just replace. So I thought, well, let's save a lot of complicated pain in the butt stuff, and we'll just coat over top of this wire. And you can put that on there fairly thick, and it's going to be fine. And you want to push in when you're doing that with bared wires, because the idea is to get it to soak into the wires. So now we're going to have to let that dry for about 20 minutes or so. So I'm going off camera. I'm going to let that settle up and dry. And then we're just going to go ahead and reassemble. Because like I said, this positive wire is in fine shape. I'm not going to bother. It's not going to make any difference as far as amperage draw goes. So we'll just leave that alone, and we'll be done and get this tool back up and running for some more work. Okay guys, so before you reassemble, you're going to want to test to make sure that that's all that's wrong. So you can take your battery. It only will plug into this connector one direction. It's impossible to put it backwards. Now I went ahead and I reinforced these wires too. So we're just going to plug it in like so. And we're going to hold the motor in our hand and the switch in the other hand. And just everything works. So now we just got to reassemble all this mess. So anyway, while that's still going, we're letting that dry. Now we've got to put all this back together. That is the fun part, which is going to probably take a few minutes to do on video. But you know what? We got to do it. So it's kind of not an option. And yeah, these are directional. So it's keyed. So, got that in. That's going to go that way. That in like that. This is going to go this way. And we want to make sure we get this motor locked in. Now, for the motor, you got the two tabs. It goes in this direction because it locks into some tabs. Okay, just like so. Now, you're going to also have to finagle with this stupid light. And that's where you've got a slot in here. You've got to get it fed into. I said it was finagling, didn't I? It's going to be a bit of a pain to do, but we get the motor, the wire in there. This routes through here like so, down in behind the slot. The hard part is actually getting this stuff fed in here, but there's a little slot in here where this wire tucks away into, and this all sits into a little track. That goes like so. Make sure that this is on this side. Let me zoom out. That's in there. That's good there. That goes like so. Oh, we got jam up. Alright. There we go. Getting all this tucked back in precisely the same way can be a little bit frustrating. Okay, I need to take a quick break. I'll be back. Alright guys, some of this you're probably not going to catch on camera, but there's nothing I can do. Anyways, so we got to get the forward and reverse switch installed in this. So we're going to have to kind of pull up a little bit on the switch. Get that tucked in there, like so. That's in. Alright. So, it's a little tedious. Next thing we got to do is we've got to put our safety bar in. And that just tucks under, kind of like so. And this is also spring loaded too. So this can be a little bit tedious as well. So I'll show you a close-up, and that's what things should look like there. Okay, so next is our main power switch. We've got to get this in. And that should just sit like so. Now the LED panel tube, by the way, only goes in one way. Okay, so you're going to have to make sure you take a photograph of that. I would take photos of everything, to be honest, because your photos are going to be better than the print either way. So that's what it should look like. Okay, so you see the direction of the panel, you see what's showing. Otherwise, if you get it backwards, no big deal. You won't know what your battery level is. So, kind of pick your battle on that one. So, next thing we gotta do is see if our side cover is gonna fit. Then we'll know if everything went back together properly. And, yep, looks like it did. Okay, so now we got that together. Now we need our drill. And our Torx bit. So it's tedious more than anything. It's not that it's really complicated. It's just tedious. So while you hold the sides together, probably want to put your drill on a slower speed because you don't want to shatter the frame, because you only need these just snug. So basically about there. Now you would have gotten a spare rubber boot or gear cover with your oscillating tool. I am changing mine because it has a bad rubber tooth. And besides, after all the torture I've put it through and fixing this thing, it deserves a new one. Okay, so that's the old one. Now you've got this little plate. It's got to go back in as well. And it just pops into place, and that's it. And that keeps that part nice and secure and rigid. Now there's the new boot. We're going to put it on. Okay, so that's all fixed. Battery. Oh no, we can't push the button because we don't have a headpiece on here. That's okay. So we'll find out where that hole is. Right there, the safety bar. Push it down. And that's not going to be long enough. You also know if you get your safety bar in the right way. So we need something a lot thinner to push down in on that. Maybe we can do it with the wire. Yep. Both directions are working. That's it. Fixed! Thanks for watching, guys. Hope you enjoyed the video. If you have any questions, feel free to ask, but I think we've pretty much covered everything. It's really not that hard, but I would definitely suggest upgrading to a slightly thicker gauged wire like I did. Make sure it does have a silicone type of skin on it. Really does make a huge difference of heat transfer, because when you're running the snot out of one of these tools, you are building a lot of heat up in there. Even though you do have cooling fins for the motor, and you've got all these vents, the wires themselves, because when you're creating electricity, it's kind of like an arc, right? You're drawing a lot of power there, right? Because these are like 1.5 amps or something, these batteries. But even with that amount of power and you're just going nuts with it, yeah, it's definitely going to draw some power, so you need some slightly thicker wire. Now, the other thing we want to check is to see if our power indicator light board is in the right direction. And we just had our good wire. Yep, power indicator is working. Good. So, take the old rubber boot. Garbage. That's it. That's all she wrote. Thanks for watching. Hope you enjoyed the video. And yeah, whenever I have to fix other cordless tools, I will do videos for you guys when I need to do it. But don't ask ahead of time, because unless I have a broken tool, it's not going to happen. Anyways, see ya.